Hey guys, so for my last video today, like I said, not finishing up 2.2, I'm leaving 3.2, I'm leaving that to next week. What I am doing is specifically pointing out one example of a problem that I went over with Dr. Freedom this week that I thought was really interesting and a little bit different than some of the stuff that we've been doing. Because if you remember, we talked about the idea of parametrization a couple lessons ago. Parametrization being, and in fact, I'll pull up the definition so that it's a little bit easier for us to kind of jump into this problem. But okay. A parametrization of a curve C in R2 is a function G from R2 to R2 whose image is C, right? Where the image is the curve. The example they gave was the unit circle where you've got cosine t sine t, f of t equals cosine t sine t. The image is, obviously the curve itself. So that was a good example. But then the book asked us, they wanted us to find the parametrization of a sphere. So obviously cosine t sine t is not going to work anymore. And before I get started, I'm not going to claim credit for figuring this out. Oh, that's not purposeful. Okay, I'm not going to claim credit for figuring this out. I went to Dr. Prudhomme and it makes sense, but this level of creativity in figuring out math stuff was not something that I did. But I thought it was really cool and really interesting. So we're going to say that we've got a sphere and it looks like this. And if we think about it, we've got a couple different things going on. We've got 3 dimensions. We've got X, Y, and Z. Now, the thing that we have to think about is that when we were dealing with cosine t, sine t, our point was that as our x was varying, our y was varying, right? Like both of these are sinusoidal functions, they're periodic functions, and they increase and decrease periodically, right? And the point was, we've got a curve. The things are increasing and decreasing periodically. But once we come into a sphere, we've got other increases and decreases to worry about. Specifically, we have got to worry about the fact that our cross sections are going to get smaller and smaller as we reach the edges, right? And we've also got to worry about the fact that this height, the sort of like circle representing the height, is also varying. So let's think about it. If we've got X and we've got Y and we've got Z, we got to think about how all these things are varying. Now, if we start out with cosine T, X needs to be varying in 2 ways, right? Like it needs to be varying within, one circle itself. It also needs to be varying as you move up the sphere and the x's get smaller because the whole circle's getting smaller, right? So that means that we have to add in another periodic function multiplied times this representing x. And we're going to choose sine t. Now, the same thing is absolutely true for the y, again, on the same circle. We've got 2 different types of variation. We've got the variation on one individual circle and the variation as that circle moves up. So it's going to be sine t, sine t. And as Dr. Prudhomme and I discussed, it really doesn't matter whether we pick sine or cosine as the thing that we're kind of adding in here, but we have to stick with it. Then for the height, has to be cosine t. because we got to throw in another periodic function to represent this height and how that's changing, right? But of course, it can't be the sine because, you know, with the x's and y's, we're kind of dealing with the same thing. We're dealing with that same circle, and it's kind of varying in the same way. Whereas the height is kind of a whole different thing. And so we need to use a different periodic function, right? But this would be our end results for our parametrization. Instead of cosine t sine t, we've got cosine t sine t, sine t sine t, cosine t, right? And, you know, if you wanted to check this, you could always, you know, figure out the definition of a sphere is x squared plus y squared plus z squared, right? Equals 1. And so the way you could figure that out is to solve that, right? To plug everything in and figure out if you end up with 1, and you will, but if you really wanted to plot that in. But here's the point. What I thought was really cool is that the entire key to this problem, and really the entire key to parameterization, is to think about variation. Where are things varying and why are they varying and how can we represent that, right? In the original, we just had one circle, right? And so that means that, you know, x was varying, you know, we were like, let's say we're starting here and we then move to here, right? Our x varies, right? Here it's like 1, say if we're on the unit circle, it's 1, here it's 0. Our y varies, right? Because here it's, I don't know where we are on the circle, but let's say it's like, or sorry, here the x is 0 and here it's -1. So let's say we've got a y of pi over 2 and a y of pi here. Both of those things are varying, right? So you've got cosine t sine t. And of course, you know, cosine representing the fact that on a unit circle, you know, you kind of got x corresponding with cosine, you got y corresponding with sine. But then you move to the sphere, and not only do you have the variation within a circle itself of the x and y, but you also have the variation of the fact that you've got multiple circles stacking on top of each other, getting smaller and smaller, right? And so you kind of got, if you think about it, if you think about this sphere, and you think about the fact that we're representing this whole variation as a sine thing, well, here, right, it's the x and y's are small, then they get bigger, and they get bigger, and they get bigger, and then they get smaller, and they get smaller, and they get smaller. And that's very, you know, that is periodic, right? So we have to represent that with an added on periodic component, and we chose sine, right? And then finally, you've got height. And that's something that's also varying in the way that, you know, it gets smaller and smaller and smaller, and then it goes bigger and bigger and bigger and smaller, 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 you know, it's also periodic. So you have to use another periodic idea or component thrown in for that portion. And I thought that was just like really cool to kind of think about how you can expand out the idea of variation and periodic functions and sinusoidal functions out to more dimensions than just the unit circle. In pre-calculus right now, we're doing a lot with the unit circle. And I thought that was just really, really interesting. So that is, I believe, is all that I have for us today. That was all the videos that I wanted to get to today, but I hope you enjoyed kind of going down that little tangent, and I hope you enjoyed learning about 3.2.